Hello, I'm Atsushi Kawasaki from Toshiba. I'd like to talk about multimodal trajectory prediction for autonomous driving without a detailed prior map. At the beginning, I will explain our motivations. An autonomous vehicle needs to drive safely by predicting trajectory of other traffic participants. We pick two difficulties for trajectory prediction. The first is variability in scene structure. Prediction tasks need to be able to accommodate a wide variety of road shapes. The second is multimodality. For example, when other vehicles will approach the intersection, we cannot uniquely determine their future trajectories. So we need to present multiple trajectories in diverse environments. To overcome these difficulties, it is necessary to use running map information. We can classify map usage into two types. One is using prior map and the other is not using prior map. For example, a prior map is an HD map that contains lane information, as shown in lower left image. Lane information makes prediction tasks easy because these information denote road rules such as legal traffic direction and valid path through intersections. However, the cost will be higher when we create such a map in all areas. In the case of not using prior map, costs of infrastructure are low because perceptual data-based maps are used instead. As a perceptual data, we use 3D point measured by LiDAR sensor equipped on the eco vehicle. However, such maps do not explicitly denote road rules, so prediction tasks become even more difficult. We will tackle the prediction tasks not using prior map. This slide shows a contribution. We propose a novel GAN-based framework for multimodal prediction using only perceptual data-based map. We introduce a function which can keep the spatiality of trajectory and the map in a discriminator. So discriminator can capture an overall road shape from them and distinguish whether predicted trajectory follow road rules. Lower right figure shows our result. Pink line are predicted trajectories. We can see that our method can predict wide or tight turning trajectory following road rules. Let me introduce our proposed GAN-based prediction framework. This is our generation module. Our generator combined LSTM is a CVAE encoder-decoder architecture. Our goal is for CVAE to run the distribution of multiple output conditions on the input trajectory and the map. Condition map feature is obtained via CNN and trajectory feature is via LSTM. Decoder LSTM takes map feature, trajectory feature, and random sample tangent variable as input, and outputs multiple predicted trajectories. Next, discrimination module can distinguish whether generated trajectory follow road rules or not. In our discrimination module, we introduce a function which can keep the spatiality of trajectory and the map. In conventional method, the map features by CNN were flattened and concatenated with the trajectory feature because the representation format of them are different. However, this approach ignores spatiality. In our method, we project trajectory onto the map by using probability density function (PDF) and convert them to probability map. As a result, we can get the spatiality. We input the future map and the probability map of predicted trajectory to convolutional LSTM, and convolutional LSTM distinguishes real or fake trajectory by considering an overall spatial and temporal features. This slide shows the prediction result by our method and the baseline method on the NUC dataset. Input and output trajectory are shown in orange and pink line. In the first column, graphs show driving lane and the path colors show lane directions. We can see that our method predicted diverse multimodal trajectories such as going straight and turning left and right. Additionally, our predicted trajectories are on lane more face-free. Please see the demonstration of our work. Prediction targets are oncoming vehicles. Red and orange rectangles depict ego and other vehicles. Predicted trajectories are plotted in pink lines. We can see that each predicted trajectory follows road rules.